Hello my dear students, welcome back to Learn Physics. In today's video, we are continuing with the kinematics revision questions, which and all topics I covered till now, the last all the chapters summarizing all the important points, and we were working out some exercise questions from Pandey sir's book. Today also we are continuing the same thing. In today's video, we are starting with some of the exercise questions, graph questions. Okay, so the first one is the velocity time graph of a particle moving along the x-axis is shown in figure. So velocity time graph is given like this. This is velocity and here it is time, and here it is given like this. It's a straight line graph, and afterwards it's given here like this. The corresponding displacement time graph is. So we need to find out the displacement time graph. I know this may be easy for you because velocity time graph with a slope, a straight line with a slope in the positive direction, that one will give you acceleration. So this is uniformly accelerated position, and here this is velocity remains constant, that is under constant velocity. It's moving with a constant velocity or uniform velocity. So how can we draw the displacement time graph for uniform acceleration? How the displacement time graph will be? It will be in like a parabola. Right? So when it is increasing, after that negative velocity and constant. So if it is negative and constant velocity, it will be a straight line graph which is coming in the downward direction. So this will be the displacement time graph. So here it is coming as option D. Okay, so its velocity time graph is, this is uniform acceleration, this is for constant velocity. When that uniform acceleration, when it is converting to a position time graph, this will be, the uniform accelerated position will be like a parabola, and the constant velocity which is negative, so it is decreasing with respect to time. Clear? So the next one is, the given graph shows the variation of velocity with displacement. Which one of the graph given below correctly represents the variation of acceleration with displacement? So here it is velocity and time graph is given, and the values also it's given like v0 and this is x0. Right? So how can we find out this velocity time graph here? From this equation, this is not velocity time, velocity and displacement graph, and we need to convert that into corresponding acceleration displacement graph. So from the velocity position graph, we need to convert that into acceleration displacement graph, AT graph. How can we convert this into acceleration? So this one, we can write down this as an equation. So it's with a negative slope. Velocity is decreasing with respect to time. So it has a negative slope. How can we find out the negative? Y is equal to mx plus c. This is the equation for a straight line. Right? Here this is y-intercept as v0. So when we are writing down the y-intercept, y coordinate as v, that is equal to m. This is decreasing with respect to time. So it will be a negative slope, minus m into x0. x0 no need to write down, x as x only. Here it is y-intercept as v0. To find out the acceleration displacement graph, we can find out the acceleration from this. dv by dt equals minus m into dx by dt plus v0. Okay, that v0 is differential of a constant is equal to 0. Therefore, we can neglect that. Again, minus m into, what is dx by dt? It is v, which one we got it as minus mx plus v0. Therefore, m square x minus mv0. So this is acceleration. Acceleration and displacement equation, we got it as a equals m square x minus mv0. From that, what we are understanding? See, acceleration and displacement graph will y equals mx plus C. So here M, the position of M is occupying with a squared value which will be a positive thing. So slope is positive but its y-intercept is negative value minus MV0. So y-intercept we are getting it as a negative value and the slope is it's positive slope. So acceleration is increasing with respect to displacement but its y-intercept is negative. So how can we represent that? See here, y-intercept is negative, so it should come here. Acceleration will be representing at the negative intercept and it is increasing with respect to displacement. So this will be the acceleration displacement graph. Clear? So from this equation, since it is a straight line, we can write it as y is equal to mx plus c. So the corresponding values y is v and x is x only. We are giving like that and converting to acceleration, and while getting the acceleration we understood that y slope of the ax graph will be positive value but the y-intercept is negative value. Slope is positive means it's increasing with respect to the displacement. Therefore, it's increasing with respect to the displacement and the y-intercept started from the negative value. Clear? Next question is, the displacement x of a particle in a straight line motion is given by x equals 1 minus t minus t square. Okay, the displacement of a particle in a straight line motion is given like x is equal to 1 minus t minus t square. The correct representation of the motion. So how can we represent this motion? It is xt. So position, displacement or position time graph, how can we represent for this? So first we need to identify which kind of motion is this. So whether it is increasing or decreasing, that and all we need to find out. For that, first I can find out dx by dt. Velocity I am going to find out. 0 minus 1 minus 2t. Like that I am getting. So V I got it as minus 1 minus 2t. So can you compare this equation with any of the equations in equation of motion? We know V equals u plus at. When I am comparing that one, u I got it as minus 1 and a I got it as minus 2. So from this what I understood, acceleration is negative. Negative acceleration and velocity also decreasing with respect to time. So what about the position time graph? Position time graph also will be decreasing with respect to time and it is a uniform accelerated motion. Since it's a uniform accelerated motion, anyway it will be a parabola. Right? So the position time graph we can represent it as the displacement, it is decreasing with respect to time and it is acceleration is negative. So the graph will be like this. Yes, the answer is B, correct. So it's a parabola. Clear? So next one, next is not a graph question. The vertical height of a point P above the ground is twice that of Q. Okay, from the ground, a vertical height we are considering, with that height is P. From Q, it is twice that of Q. Okay, the particle is projected downwards with a speed of 5 meter per second from P, and at the same time another particle is projected upward with the same speed from Q. Both the particles reach the ground simultaneously. Then PQ equals 30 meter, time of flight of stone equals 3 seconds, both A and B are correct, both A and B are wrong. So we need to find out PQ and time. Then only we can find out the answer from the option. So vertical height of a point P which is at a height twice that of Q. So I am considering Q at this height. So if Q is at a height h, then what about the point P? P will be at a height 2h. Now, a particle is projected downward with a speed of 5 meter per second. From here, u is 5 meter per second downward direction. And apart from P, and at the same time, another particle is projected upward with the same speed from Q. So, from Q, another particle is projecting upward direction with the same speed. Okay, so how can we find out the time required? Both the particles are reaching at the same time on the ground. We need to find out the PQ distance. PQ distance we need to find out, and time also. Now, how can we find out the distance? So I am considering here this as the origin. If this is the origin, from here downward direction it will be its negative value, and the upward direction it will be positive value. Right? So here S is equal to, for the point P, okay, S is equal to ut plus half at square. If I am substituting that, S is equal to ut downward negative minus phi t, and it is minus half a t square. Okay, A is 10. So here for the point Q, S equals, that also, here it is 2h, right? So it is negative, minus 2h equals minus ut plus half a t square. Here I can write it as minus h equals plus phi t minus half a t square. So here the downward direction we are considering it as negative, and upward direction we are considering it as positive. So since it is the downward direction, minus 2h, it is coming downward, minus phi t minus half a t square. So here it is minus h is the distance, and phi t. So from here if I am considering this is moving upward, so it is phi t plus half into a t square. Right? So while solving these two, how can we write down? See here I can write down h as minus 2 into phi t minus phi t square equals minus phi t minus phi t square. Therefore, minus 10t minus plus 10t square equals minus phi t plus minus phi t square. So, while I am taking to the side, I got it as minus phi t equals minus 15t square. Therefore, t. So, again here minus, so sorry, here it is minus h, right? So here we considered it as the, so no need to consider this negative sign. So here minus 10t square. Therefore, when we are taking this to the side, 15t square equals 5t square, and t we are getting it as 3 seconds. So while getting this 3, we can find out we should find out the value of h. Therefore, h equals minus h equals 15 minus 5 into 9, 5 into 9. Therefore, it is 15 minus 45, that is equal to 30. So here this will be 30 meters. And height h is equal to 30 meters and t equals 3 seconds. It's correct. So both A and B are correct. Here in this question it is given, the options were PQ equals 30 and second option was t equals 3 seconds. Both A and B were wrong. Both A and B were correct. That was the option. So here both A and B are correct. So I'll explain you this question once more. So from P. First it's given we are throwing an object downward direction with a velocity of 5 meter per second, and we are a point H, Q is there, this P is twice the height of Q. Okay, so here we considered H and this is 2H. Since it is coming at the downward direction, U is negative. It's coming at the downward direction, so U is acceleration also negative, and this minus 2H. This is the downward direction. So here everything is negative. And here next is acceleration. S is H is negative. Acceleration downward, it's negative. We are throwing it upward direction. Therefore, it is positive. So velocity is acting in the upward direction. Minus h. So here while solving these two equations, so here we got the two equations for the displacement, and while solving we got the value as t equals 3 seconds and h is equal to 30 meter. Here the sign which we are using, that one you should be careful. Okay. Next question is, the displacement of the particle is given by x is equal to t minus 2 the whole square, where x is in meters and t is in seconds. Find the distance covered by the particle in first 4 seconds is. So we need to find out the distance covered in first 4 seconds. So how can we find out? See, distance is given and relation with the distance and time is given here. How can we find out the distance covered? See, if we are getting what is the velocity time graph. From the velocity time graph, we can find out the distance covered by taking the, by taking the area under the graph. So in that case, we can find out first the velocity dx by dt equals 2 into t minus 2. What will be the acceleration? D square x by dt square or dv by dt equals 2 into t minus 2, 2t. Right, 2t is the 2t minus 4, therefore 2 is the acceleration. So it's moving with a constant acceleration 2 meter per second square and this velocity is 2 meter per second. Right, then here we can find out the velocity time graph. This is time and here it is velocity. When t equals 0, what will be the velocity? Velocity equals t equals 0, velocity is minus 4 meter per second square. Minus 4 meter per second square. And then when t equals 2, what is the velocity? When t equals 2, velocity is equal to 0. Then what is the velocity when t equals 4 seconds? We need to find out till 4 seconds, right? So here when velocity equals 4, when time equals 4 seconds, v will be equal to plus 4 meter per second square. So if I am drawing a graph relating to that, so here I will get like this. This is 4 meter per second, here it is minus 4 meter per second square. So how can we find out the, so we got the value like this. Now how can we find out the distance traveled? Area under the graph. So from here to here, what is the area? This is the area. And here from here to here, the area will be this one. Right, so here area under the graph, distance covered will be equal to area under the graph. Area of this portion is half into base into height plus area of this portion is half into base is 2 into height is 4. Therefore, here we will get it as 4 plus 4, that is equal to 8 meters. Here, clear children? So here we have a displacement position graph, displacement time relation is given, x is equal to t minus 2 the whole square, and from there we need to find out the distance time graph. Is another method is we can find out from the velocity time graph by taking the if it is under uniform acceleration, we can use the same formula. Okay, clear children? So these are some of the questions which we are discussing today, and I hope this is useful for you. And if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.